Okay, and we're going to finish up here in this linear problem, linear graphing, the scatter plot that we'd started in the previous video. Let's take a look at where we were. We had found the slope. We found a model using 2 points. We then put the data into the calculator and we graphed it and we looked at it, and it was pretty close to a straight line. And we found the model using the calculator. That was found a second for the calculator to come in line here. Okay, that was found in linear regression. There it is right there. That's what we had here. We graphed the line on our calculator by plugging it in y equals. We typed it in there. We drew it in there. We asked what our y-intercept was. In this case, our y-intercept is 0,313.37. That's this value right here. That means our initial value of the function is 313.37 ppm, which is in this case ppm is parts per million. Parts per million is our initial value. It's a little bit different than what we had here at our beginning number. It's a little smaller than this, so that means there is a small amount of difference in the graph that we had for a model and the actual graph. You can see it here. It's a little lower, and this is a little lower, this is a little higher. It gets close to these points and it's a little lower than that point. Alright, and we're going to answer our last question here. It says, some climate scientists have warned that if the CO2 concentration in the atmosphere reaches 450 parts per million, it will lead to irreversible catastrophic global events. Use your calculator-generated linear model to predict when this would happen. So this is why we have this extra stuff here, so that we can make a prediction. And we can use that, we can just do that by putting in our 450 for our second graph and looking at when it will intersect this graph. So that's why we have more on the graph. That's why we included a little bit more on the graph so we can make that prediction. So to do that, we just do second calculate, intersect. We hit enter for first curve. That's y1. That's what we want. We push enter. Second curve is the 450. They push enter. I guess we're going to move over closer to the guess to the right. We push enter. So it looks like that the x value here is 94.88. X equals 94.88, which is how many years? This is years after 1960. So that means we would have to add 94 years to this, or 95 years to this 1960. 1960 plus 94 gives us, so the year 2054, in that year we're going to reach 450 by using our model parts per million, if this trend continues. And you can also verify that on with your formula by just taking your 450 equals, so we take your y equals mx plus b, y equals 1.44 1.44x plus 313.37, and we say y is 450 equals 1.44 times x plus 313.37. If we solve this equation, we should get this answer. If we solve this equation, subtract your 313 and divide by this, we should get 94.88. So even if we didn't have a graphing calculator, we should have been able to plug this 450 in for y and solve this. All right, and that concludes the section covering linear models from data, and this would be what you should have on your worksheet when you worked it out.